Well, in the previous videos, we did question 5.1. Now we are going to do question 5.2. And then the question says, simplify 4 sine x cos x over 2 sine squared x minus 1 to a single trigonometric ratio. So I'm gonna write the question here. We have like 4 sine x cos x all over 2 sine squared x minus 1. Now, to simplify this, we are going to use by the help of some trig formulas, okay? Like, as I can see, 4 sine x cos x, I remember there's a property that says 2 sine x, okay, I prefer to write it like this. The property says what? Sine of 2 theta is equal to 2 sine theta cos theta. But over here, I can already see sine x cos x here. So it's the two looks like similar. So what can I do? Because I have 4 there, okay, I can just write, instead of writing 4, I can write 2 like this times 2 sine x cos x, okay, all over, okay, because as I was saying, now if I do that, we can see this part will be the same as that one, okay, can be reduced to that. Now for the denominator then, okay, there were 1 here, okay, for the denominator then, we have 2 sine squared x minus 1. I know that there's a property that says this for cos, for the compound, for the double angle, sine cos of 2 theta is equal to 1 minus sine squared theta. But over here, I have 2 sine squared x minus 1 instead of 1 minus sine squared. So what I can do is this. If I want to get it the same as this, I can just put a negative sign like this and then reverse the order. Okay, instead of writing 2 sine squared x minus 1, this will become, okay, this will become then 1 minus 2 sine squared x, okay? So such that if you times by the negative 1, you put the negative here. It's like taking negative 1, okay, out there. If you times by negative 1, you will retrieve 2 sine squared x minus 1. So now we'll notice that we have exactly this one. Now we can reduce this by saying 2 times sine 2 theta over negative 1 times cos 2 theta, okay? And then this all parts, okay, will obey this other formula, follow that formula that says tan of the angle theta. That's the formula. Over here, actually, it's x, okay? Sine 2x cos 2x, and then theta will be equal to sine theta over cos theta. And now this will be simplified. This will be 2 over negative 1. Okay, this part just makes 10 to x. So this is just equal to negative 2 10 to x. Okay, and then the question says, the following question says, hence calculate the value of 4 sine 15 degrees cos 15 degrees without using a calculator. Leave your answer in the simplest form. Okay, the shortest way of solving this problem is like, okay, maybe like I need to move and write the same property here. It's 5.2. 5.2.2. The question says 4 sine x, no, sine 15 degrees cos 15 degrees over 2 sine 15 degrees minus 1. Okay, now the shortest way of solving this problem would have been that to just substitute x by 15 degrees, okay, and then use the reduced form, the simplified form that we got here, because this is, if I write, okay, of this x here is just 15 degrees. And then we already reduced, we did work it out in the previous question. So this will be just equal to -2, 10, okay, to 15 times 15 degrees. And then this is the same as -2, 10, 30 degrees. Now, okay, over here the calculations become simple then, because we can just draw our triangle, okay, and we know that this angle, if this is 30 degrees for instance, and then that must be 60 degrees, excuse me, that must be 60 degrees, okay, because it's a right angle triangle. And then this will be 1, and then that will be √3, and that may be 2. So now to work out 10 of this, 10 or 30 degrees, then we just want to say 10 or 30 degrees will be opposite over adjacent, okay, because 10 is opposite over adjacent. We did it, I want to say here, 10 is, every angle is y over x, opposite over adjacent. So this will be 1 over square root of 3. Then we can substitute here, it's going to be -2 times 1 over square root of 2, 1 over √3. And then this would be just -2 √3. Thank you. Or someone else may rationalize the question. Say -2 √3 over 3. Thank you.